welcome back. Thank you for clicking on the next video. Okay, let's most probably you're coming from the last video. I think the question statement was like a very uh, basic and feels like a gimmicky question. Means like a LeetCode wanted to just give any question and they gave it. So that's why I'm thinking of making another one. Let's continue and find another problem statement if something because like at the end of the day I want something to be more fruitful for you. Let's see how it goes. So in the last I solved this. Let's quit it and reopen it so that it refreshes. Okay, design has set, has map. I am not going to touch this again. 1 bit and 2 characters. What does it mean? Should I do it? Pivot index. I think this can be helpful, or find the smallest ladder than the target. A minimum cost climbing stairs. I think this can strike some interest, but let's just maintain the consistency. Let's not get too much addicted to the question. Let's do this one. Okay, let's see how it goes. Okay, is 1 bit character. We have 2 characters. The first character can be represented by 0. The second character can be represented by 2 bits, is either 1 0 or 1 1. Given a binary array that ends with 0, return true if the last character must be a 1 bit character. What? Bits equal to 1 0 0. True. The only way to decode it is 2 bit character and 1 bit character. So the last character is a 1 bit character. God knows what does it mean. Input is equal to 1 1 1 0. Output is equal to false. One way to decode. And what is this language? Oh, that's the end of question. Exam. Okay, it's segment. Okay, so you have 2 special characters. How I am going to understand this question? So we have 2 special characters. First character can be represented by 1 bit. I have 2 special characters. Okay, special character in the sense means something like this and something like this. Okay. So first character can be represented by this. Okay, and second character can be represented by either this, someone typed, and this. Okay, so let's say you type something either 1 0 on your keyboard and then hash will come. If you type 1 1 also hash will come. If you type 0 at the rate will come. So that's something I get it now. Given a binary array that ends with 0, return true if the last character must be a 1 bit character. What? Given a binary array bits, given a binary array that ends with 0, so in every input list it would be ended by 0. Return true if the last character must be a 1 bit character. What? Feels like my English is bad, or I don't know, but sometimes it's really tough for me to understand even the problem. The only, okay, now I'm looking at the example one. Example 1 has an array which says 1 0 0, and as promised the last element is 0. The output says yeah, that's verifies the conditions. Explanation is the only way to decode it is 2-bit characters and a 1-bit character. 2-bit character which is 100. So I'm assuming the first 1 and 0. So okay, so the list is this, and I think the first 1 and 0, and then in the last there is a 0. So the first one is translated to what we say has. The last one is only the remaining, which is translated to at the rate, assuming I'm not getting it from the language of the question. So the last character is a 1-bit character. Last character is, yeah, I know it's a 1-bit character. You only don't know in the question that it's a 1-bit character. The first character can be represented, and the last character can be represented by tricky, man. Not tricky, gimmicky. The one way to decode it is 2-bit character and 2-bit character. Okay, so 1 the only way to decode is 2-bit character and 2-bit character. Okay, so 2-bit character and the 2-bit character. Okay, so the last character is not the 1-bit character. Okay. Now I'm getting the question. Okay, let me try to. In case I think since you are following me, probably you would know by yourself also, or probably you are more intelligent than me. I'm slightly not that intelligent, but feels like I think in a unique way, and same goes with you as well. Everyone ways of thinking slightly differs, but I don't take it as a disadvantage. But yeah, it's cool. Let's see. So at the end of the day, the question is the very last element in the array, is that a 0, which means first, which means the, let's say, the at the rate symbol. Okay, or is it the 0 of has? That's something the question is. Are you getting? No, most probably. So again, at the rate is represented by 0. Okay, and has is represented by 1, like 1 and then ending with 0. Okay, and then I gave you the keyboard inputs, what I typed. Let's say I typed 0 and then 1 and then 0. Okay, so you need to understand like whether this 0 is a 0 which I wanted to type for at the rate, or whether this 0 is coming from this, which is like I wanted to type hashtag. So in a way, in this case I wanted to type at the rate and then hashtag. This is what I wanted to type. Okay, let's say another scenario where like it could have been 0, not like 1 1, let's say 1 1 1 1 and then 0. Okay, let's take this example. So in this scenario, 0, again, the very first assumption you can make is it is an at the rate. Okay, but if you use this one as an at the rate, this one can only be hashtag. Okay, and then this one can only be the hashtag. Correct? Okay, let me make one more over here. Okay, now let's see. Again, you can assume this is an at the rate, and then this will become hashtag, this will become hashtag, but then this is not a valid pair, no? This is not a valid pair. Okay, if we go another approach, let's say if I take this as a yeah, this is a hashtag, this is a hashtag. So wait, this is a hashtag, this is a hashtag, okay, and then 10 can be a hashtag also. Okay, so at the end of the day, I understand the question now. Okay, so can I say the question language was correct? I somewhat agree the question language is correct, then my reading ability is not that good to understand it in the first go, unless I see the language of the question and try to solve it. Okay, let's see next thing, and how can I solve it. Is a 1-bit character. So if the number of elements is odd, whether it is 1, okay, let me check. 1 1 1 3 4 and 5. If the number of element is odd, then 1 2 3, whether something 0 is here also. 1 2 3. If I make it let's say 0, okay, if I make it 0 0 0 nothing, so this will become at the rate. 0 0 nothing, this will become at the rate. 0 is nothing, this will become at the rate. No, this is not a valid pattern now. So by doing this, I don't think if I assume that anytime the input is odd, the length of input is odd, it means only the same thing. Okay, can I do this just by looking at the not the length but the making the pair? From the starting itself, if I make a pair this, if I make a pair this, what was the before? Okay, no, what is the okay, let's say if this was 1. Okay, now I know if this is 1, and okay, anytime if it is 1, I need to look at the next one and then say feels as if now we have a question. An immediate thing which came in my mind was like to use stack, but I don't know how. Let's see. Let's say I have this. I don't know how long the number of elements are there. Let's say there is X number of things. I don't know what they are. If I take this element, I know it cannot be okay for I in range length of bits. Okay, and then number is equal to bit is equal to bit size. Okay, if bit equal to 0, then what? Translate it to, let me create another list, something like that. Okay, L dot append, let's say at the rate. Okay, this I'm not doing like in exactly the question direction, but I'm just thinking in the way I imagine the question. Okay, now if bit equal to 1, then I need to check. Okay, I also need to remember if this is already visited. Can I skip 0 which are in the middle? Mm, 0 in the middle. If something needs to be, I think I'm thinking in the very wrong direction. There must be a way in which this can be solved more elegantly. For I and range, length of bits, bit is equal to bit of I. If bit is equal to 0, that print this. Wait a second. If somehow 0 I see. Okay, I think I'm not getting anything. Probably what should I do? If I look at the solution, that's not a good thing. For I and range, ones like I'm thinking for a more structural approach, step-by-step thing which I can think to solve it, but probably I'm not making that effort. Okay, let's make us an effort. 0. Okay, I will do only from the starting itself, and let's make this question, and at the bottom I will have 3 more question, 1 1. Okay, and then 1 0. Let's see I'm able to solve it by going left to right or not. This would be correct, then this would be okay at the rate. Okay, this is a pair, we know. Then this is a pair, that this is a pair, then this is a okay, but okay, oh sorry, all of them should be in 0. Okay, so this is a pair, and this is a pair. Oh no, this is a pair, not a pair, single single single. Okay, correct. Pair, single single, pair. pair, single, single, pair, single, single. Anytime I'm encountering one, I'm looking for something which can like make a pair out of it. Okay, let's say I make a stack. Okay, and if I see 0, of course it means I can let's say I can append. Let me append it just let's say at the rate. If I see if bit is equal to 1, and then I append the stack in this, and then I say let's stack it. Okay, and before appending it, I check if last element is stack last element one and 0, no? I made it str plus, not here, 1 and 0. Let's take the direction, but str of bit plus str of this is equal to 1 0 is in this or this. Okay, then stack dot pop. Okay, else append that bit. Okay, and let's see what the okay, it's asking for a boolean result. I need to do it on my local PC then. Right, I just want to say the print L was there in the out of index now. What's wrong? It's 1 0, no? Str of bit. Stack. Okay, most probably it can be the stack is empty. If stack okay, if a stack is empty, okay, let me if not s, sorry, if s what does it mean? Stack is empty? No. If stack is non-empty, then go ahead and check for this. Okay, at the rate, okay, and then in this the value would be hashtag. It should be hashtag, no? one would be coming, and then say if the bit is equal to 1, then go ahead and check if a stack is, there is nothing in the stack would be appended with 1 again comes. If stack is there, I will check if the current 1 in 1 that is correct. I'm going to pop it. Okay, I'm popping it, emptying the stack, but I need to append this into the list. L dot append this thing. Okay, I need to append accordingly, like let's say if equal to 1 0. Anyway, I would append hashtag only, no? Yeah, I will append hashtag. Sorry, let's see how it goes. This should be hashtag and another hashtag, no? This is incorrect. Okay, so the next time I come in this will append, and then I will come on here, one will come, sorry for that. Sorry, 1 will come, 1 will go here, and then stack is again empty. 1 would be appended. Sorry, stack is not empty. 1 would be, stack do not exist, means like there is, stack is empty, no? If stack is empty, then I am going to append it. The next time it comes up with a 0. Yeah, when this should pass, no? Hashtag should be appended, and then so I need to diagnose it. Let's debug it. What? Array man, will it not go to the loop? Oh, sorry. I need to probably here also. Okay, 1 was appended to the stack. Next time I equal to 1, bit equal to 1, bit is equal to this, stack is non-empty, so we will go inside this loop. I check if 1 is if the current plus something is matching with the, yeah, it's matching. It means 1 and 1 is matching, and we go inside it. Okay, next time I is equal to 2, and we are not going in this, append it. Okay, next time, what why at the read? Okay, got it. Okay. I need to put this in else condition. L F this do not verifies, then go and check for this now. Yeah, this can be correct now. Again, how it happened. Okay, bit is not equal to 1. Okay, so if bit equal to 1, then anyhow I'm going to go over here, not over here. So the loop, I'm not even entering this portion of the code. How? I need to enter okay, so I need to enter this portion regardless of but in the at the same time zero can't be there now. 1. Okay, if I look at the question, if 0 is there, first I should have checked if it is making any pair with the stack. Then I could have appended if 1. Okay, if I make it something here, else if bit is equal to 0, else now it's more of a just trying. Okay, let's look at the solution. I think okay, so the intention behind this putting this as an @ was in case I am able to translate it into the character representation, I would be seeing the very last element if that is matching with the what we say, the 0, and that's how I was thinking to approach it. Okay, so let's see. Okay, let's ask this. If bit is okay, so this is the approach which I was thinking. Let's see how it is. For bit in bits, if bit is equal to 0, then I needed to check if the stack is empty. Okay. Let's go back a little bit. What? Okay, why I'm here? Wait. Yeah. Okay, so this was something. Okay, now what the question is saying, if the question, the approach, if bit is equal to 0, then I need to check if the stack is there. If stack is there, then I needed to l dot append hashtag and then pop. What does it mean? If stack, if I encountered any 0, I needed to check if the stack is if there is any element in the stack. If there is any element, then I needed to append a hashtag and then pop that element. Okay, else I needed to just append at the rate. Cool. Else, then this is the else approach. Again, else means if I equal to 1, l dot append fs, l dot append this, and then yeah, I think okay, the reason I had I think the condition was not required, because anyhow if this, like, we can just rely on if something is there in the stack to identify if it is has or not. Anytime a stack is non-empty, then it would be a good result, I think. Let's see. Now it's a double hash. Now my approach was, I will just look at the last element, which will give me a hash, and if it is equal to at the rate what, then true, otherwise false. Okay, yeah, so this was the approach which I was thinking. Is this an optimal approach? Let's ask. So I'm still developing the sense of whether something is optimal or not. Let's compare stack approach with a pointer approach in the terms of complexity and clarity. Is stack approach time complexity? Yes, one pass each handle is, because you are building a list that stores all the past elements. Readability a bit more complicated than the future. What is this nonsense argument? Time complexity, yes. Space complexity, okay. Pointer approach. The pointer approach is most often because it avoids extra memory calculation. Okay, let's look at the what's the pointer approach is, and let's do it directly on the so that we can do it quickly, slightly. Okay, start with an iteration number, and we need to go till the length of bit, which means less than, okay, while I is less than n minus 1, if bit I, the current wherever we are, is equal to 1, I plus equal to 2, okay, jump over 2 times, else I plus equal to 1, jump over 1 time, and then return. Okay, what is the value of I? What is this one? Then just based on number, like I would be I plus 2, 2-bit character. What? I is equal to n minus 1. Okay, by doing this, where we arrive, is that the question? I don't know, like what does it mean? I will think about it. So most probably the answer is correct anyways. What's the approach here? I have let's say a long list. I jump to the +2. I'm here. I need to jump 2 times. It's beyond it. If I'm going beyond it, then it should be hashtag. It should be the longer character. If I'm, let's say, if I'm going here, I jump to here, and I in this case was but again if I'm on 0, in this case I'm less, and it will never be added. I am not sure, like probably I will give it some time, like let my mind settle with this approach, but let's see how it goes. And I think that's the end of the solution. Let me mark it. Probably I will think about it, and probably later on, sometimes in the future, we will again come to this, because let's see. Okay, thank you so much for spending the time. Thank you. Have a great